Okay, afternoon everyone online and in the room. I'm Peter Johnson. I'm a teaching fellow in mechanical engineering, and I'm presenting about how we did labs in lockdown and what we learned from it and how that's going to influence what we're doing now. So I'm going to start with a video from a student.
Opening this box, which is probably the fluid slag. So first there's a gigantic thing that I have no idea what this is. Tubes of 3 different lengths. This box looks like a pump. So there's also this package inside the box. So inside the envelope there's 2 syringes, some nozzle. I think these are syringe tips. There's like 2 different lengths. I don't know what these are, but there's a few of these, and that's probably all.
Alright, so that was a student unboxing their lab, and so I'm going to say what were we trying to do and how did we do it and why. So thank you to Keng Wei for putting that online. So I want to say what was our general aim with the lab and what was our specific aim with the lab. So this is a quote from Henry Armstrong, who was right here when he wrote this, about 140 years ago, as one of the founding professors of Imperial. And this is about the scientific method. It cannot be taught by means of a blackboard and chalk or even by experimental lectures and demonstrations alone. Individual eyes and hands must be actually and persistently practiced from the very earliest period. So we need to place students as far as possible in the attitude of the discoverer. And so this is a photo of our students pre-pandemic using the wind tunnel to do exactly that. And the little obscure photo in the middle is showing a wall with a little pipe next to it. And they're making measurements with that little tube in what we call the boundary layer. So what we're trying to achieve is that students practice with their hands and eyes the scientific method, and in particular apply to boundary layers. So boundary layers in fluid mechanics are a really important concept. It refers to the region of the fluid flow near the boundary, hence the name, which is small spatially, but very important in terms of its influence on how the fluid flows. So, for example, if you look at the orange ball, you can see that the flow is attached to the ball at the top and then detaching or separating at the bottom. So they need to understand these phenomena to the extent that they can quantitatively predict what would happen in their engineering designs. So the way this looks to them in their notes is this. So this is week 14 of a second year module. And it says, for example, that the thickness delta divided by the length L is very small. And we get that by observing it. So we need them to make that observation. We also see in these overwhelming equations at the bottom that we want them to follow why it is that some of these terms are not important and some of them are critical and need to be included, and how then we get to an appropriate equation which can correctly predict what's going to happen. So the idea of this slide was not for you to take it in, but rather to get a feel for what the students are trying to take in. So we were not perfect at doing this lab, but it was pretty good because we had a good wind tunnel and we had a good system. And so when the pandemic came, it was a real head-scratching moment because wind tunnels don't ship. So the question was, what should we do? So the principle we came up with was BYOB, so bring your own bucket, and we provide a pump, a tubing, and this unit here, which looks like this, and I'll show you how that works. So the idea is you pump water around and you inject ink so that you can see what's happening. And we sent one of these to all of our students. So the next thing I'm going to do is demonstrate this. Okay, so I have here an acrylic tube, which, believe it or not, is full of flowing water. So the first step is we needed to make something transparent, but not just transparent, because you still can't see that the water's flowing. So we used syringes, so you can see a syringe there, and we mixed ink with water. And if I can put this syringe through this seal, which you can't quite see on the camera, but the effect will be that I can inject ink and actually visualize how the water's flowing. So we can make some important observations about the flow and relate it to our theory. And specifically because we're interested in the boundary layer, and the fluid from upstream doesn't go into the boundary layer, we put a tiny little tube underneath. I can just tip this up so that we could inject ink out of a little port here, and we can actually visualize the flow in the boundary. And you'll see how, I just need to slow the flow down a little bit. You can see it's a bit of a skill to get this right. You can see that the flow stays attached on the upstream side and actually stays attached on the downstream side until it reaches a really steep slope, and then it separates off. So that explains the shape of aerodynamic vehicles and other shapes. You need to keep them shallow at the back, streamlined. And if you look carefully, you can actually see the profiles in the boundary layer there and how thick it is or how thin it is. So the students had one of these each shipped to their house so that they could do this experiment. And you can come and have a go. We've got a couple set up here for you to have a go as well. So we had to produce 200 of them. So what we did was Keith Blackney is a really great technician in our department, and he did all the prototyping to actually build one of these that works. So this started in June last year and was ready by the end of the year. And then Northern Cast Acrylics is a company in Cheshire who deal with acrylics in particular, and we contracted to them to make 200 of these kits. So here are a selection of them being assembled by some students helping us out, ready to be shipped out to the students. So then they have one each in their house. And of course, we have to do everything on Teams because we were in lockdown. And so we did mass sessions. So we had 42 students at one time, split into groups of 5 or 6. And we had a GTA in each room. And then I would tour around. So you see some screenshots of me here and see really good engagement here. So you can see, for example, somebody's showing their flow here and here. These people are clearly having a nice time. This is a GTA who's in the room with them, and I've dropped in. And people showing their experiments in their kitchen, in their bathroom. We had a student in a country far to the east whose pump didn't work, so he hooked it up to the plumbing from his washing machine so that it would flow, and he finally got that working. And we asked him at the end if he was okay and if he had any questions. He said, yeah, I have, but it's nearly midnight and my parents are waiting to use the bathroom, so I'll go if it's okay. So everybody really came together to make it work, including the students. So that was really good. So let's have a look at some of the work that the students produced. So you can see top left, the classic shot that I tried to show just now of the boundary layer, but they also went ahead and did some of their own experiments. So this was them discovering and exploring. And these shots are all taken from the work that they submitted as part of the module. So they could really become their own investigators and discover things for themselves. And then when it came to lectures, because they'd all come through at the same time and they'd all had this hands-on experience, I could actually, so I've tinted this to show that old me is in sepia and new me is in color. So this is a snippet from a live lecture online where I'm presenting and I'm using the kit that they've already had a go on to show them the kinds of things that they can observe. So I show them a video and I stop it and I draw on it, and then I relate that to elements of the course. So here, for example, I'm showing the uniform profile, and then at the edges, you can see evidence of the boundary layer. So when it comes to evaluation, overall, we think it worked really well. We've got a quantitative approach, qualitative approach, and then some of the more subtle aspects. So this is top row quantitative data from all our year 1 labs, so 5 labs, and bottom row quantitative data from all our year 2 labs. And you can see the one I focused on in a box there. So we had some kits sent home. We had some data provided and videos. We had somebody in the lab, a human robot, doing things for the students when they weren't allowed in, and we had a remote controlled lab. And we didn't find a correlation between fundamentally which of those modes we chose. It's more just about whether it was a well-executed lab. The different quantitative colors is the 9 different questions that we asked them about, for example, this one scored quite well on engagement for reasons that are probably quite clear. So overall, that looked like it worked really well. This is cherry picked, so these are good comments. We didn't have any bad in the terms of like disaster comments, and most of the improvements that we would be aiming for if we ran it again in the same way would be more around how we manage writing the reports and that kind of thing. But overall, it went well. I'll highlight the second from last comment, which is it was really interesting. Now, we don't usually get students coming out the lab saying that, right? So that is notable, but also the point that it showed explicitly so many things that we learned in class. So this is really important. When we teach abstract things, we are abstracting something, and we sometimes take for granted that we know what it is that we're abstracting. But the students need that experience first. So I think it was really successful in providing them with the hands-on, eyes-on experience of what they're actually abstracting. I'd like to go on from evaluation to reflections, but I want to do the acknowledgements first, just to make sure they don't get left off the end in a hurry. So firstly, a massive thank you to Keith Blackney, who did all the prototyping for this kit. So really, Keith's a technician, and he's an exemplary member of Imperial staff, and none of these things happen without all of these people really going the extra mile. So Keith did a lot of late nights and extra effort to make this thing work, a lot of prototypes that didn't work first before it worked. And then a lot more people here who helped make it happen, shipping it to 167 students around the world and getting it on time. The students were amazing, actually, you know, making it work. We had a lot of goodwill, and so it was very successful in that sense. So I want to move on to my reflections and back to a quote from Armstrong that I started with. So he says, "It can't be taught even by experimental lectures and demonstrations." And this challenges me because I think if I've made a live demonstration like just now, then I've made a bit of an effort, which I have. But actually, Armstrong says, and I do agree with him, there's some things you can't learn just by seeing a demo. So that's why I brought a couple for you to come and have along with in the Q&A, so you can come and get your hands on. I think the interesting question is, what's the difference? And I think everybody says, yeah, it's different when I have a go. He says individualized and hands must be used. So the question is, are you standing around in a group of 5, or do you have one each? So this was one each, which I think was really powerful. Everybody got to have their own go. And they're actually using their hands. So it's really good, but the last bit haunts me, the word persistently. So if you've gone into the lab and had a go and come out, and you did do it yourself, and you did have one each, and you did use your hands and your eyes, that is good. But the persistence, I think, is really important. What it does is it normalizes the whole activity. So if you are investigating, if you are playing, if you are measuring, if you are reflecting on observations, that's really good. But are you making a habit of it, or is it a once in the year event that doesn't become a habit? So the challenge I take from this in the future is to make it persistent. And the great thing is, because we had to ship it, we went for a small, low-cost solution so we could have many of them. And you can actually, in principle, have 200 of these in a lecture theatre along the desks. So you can actually have regular, frequent exposure to this, so that the fact that there's water, the fact that there's ink, the fact that you can see it is all not novel anymore. And you actually start making observations built on last week's observations and normalize doing experiments. So what I really want to do now is try to normalize this as an activity that's regular rather than a one-off visit. So this is a photo of where we set up 2 kits outside the lecture theatre so they could have a go afterwards. We've done some in the lecture theatre, but I haven't got any photos of it. But there are challenges. So the department's invested in technicians who can help with demos. That's really good. So thanks to Harry for being here and setting these demos up. But there are practical challenges as well of how we actually do that, and then what time you're stealing from, you know, what were they doing instead that they're not doing anymore. So that's my challenge for the future. But we're planning a lab this year where they use this and then they go measure in the wind tunnel as well. So we should get the best of both worlds. So thanks very much, and I look forward to your questions.